All right, class, here's a little thing, is that when we did the class yesterday, I messed up on 4.5, number 31. The problem called for plotting the function from the resting kind of area of the spring as opposed to the top of the spring. What I did is I did it from the top of the spring. Then there's also an issue with the B value. So let's talk about it real quick here. So here's our little spring. This is our resting stage. And so what the book was trying to say is this. So as you pull it down, it's going to go down. And it says the highest it'll go away from the spring is 21 inches. I'm looking at it. And the lowest it'll go, or go up now, will be 11 inches. So as you take a look at that, what we have here is this right here. We have the pull down, which will actually go towards a positive way. And so, yes, we're going to try to do a model here. The model is this right here. As you pull it down, it does this. And that's the resting stage. So you pull it down, you're going to already start on the positive side. So if that's the middle, you go down. Oh, let's not do that yet. And so let me get this little guy working. Okay, it's okay. All right, so right here, if this is the middle, it says it goes down to 21 and it goes up to 11. But if this is the middle, the question is, okay, how far does it go each way? So if that's the middle, we did calculate this here. We said it was 16 here, right? But I'm not counting that 16 because this is what I did in class. I counted it back to here. We didn't need to do that. We just needed to say this is the middle area. And because of that, it's going to go up 5 and it's going to go down 5. That's what we're looking for there. So the model is this. As you start here and you let go, the spring's going to go like this. And we are looking at the positive value. So it should go like this. We're 5 centimeters away as it starts in the positive direction, and then it goes down to -5. So there's our little model right there. And if you can do that, we're all good to go there. All right, so notice that looks like a cosine curve to me, and it's a regular non-reflected cosine curve. Okay, so then let's go now the period is the problem. So 0.8 hertz, this is something I did not calculate correctly in class. So if you have 0.8 hertz, that 0.8 really just means that's how much of the cycle is done in one single second. That's not what we're trying to do for period. We're trying to figure out how long does it take to do one complete cycle. So what we do is have to make up a ratio of seconds to cycles. Now this gets a little bit too complicated, so this won't be what you're going to have to do on the test. You won't have to do ratios in order to figure out the period. So for all the questions, to figure out the b-value will be a lot more simpler than this. But to finish off this problem, let's go for it. So here it is. I'm going to build a ratio of seconds to cycles. And I have two things happening here. I have what I know already, which is 0.8 hertz, is how much of the cycle is done in a single second. But I'm looking for this. I'm looking for 1 hertz gives me how many seconds. That's what I'm trying to figure out. I'm trying to figure out one complete cycle gives me how much. And so what we do is we cross multiply. So 0.8 times x is equal to 1 times 1. Divide by 0.8 gives us this. And then you know what? I got to multiply by 10 to get rid of my decimal that's stuck inside a fraction. So I'll multiply this guy by 10, each part by 10. So then we got 10 times 1. 10 times 0.8 gets you 8. And then we're going to reduce that to a 5/4. Yes. Okay, that gives me the period. So it actually takes 1.25 seconds. 1.25 seconds to complete one full cycle. Okay, then that's cool there. Now let's put it all together. So since it takes 4/5 of a second to complete a full cycle, I can put this now as that little formula there. So b is equal to 2 pi over the period. And then we go for it here, 2 pi over 5/4. And then what we have to do, since this is a complex fraction, we're going to have to write the 2 pi as a fraction, 4/5 is a fraction, and then we keep change to multiply, and we take the reciprocal, which gives us 8 pi over 5, which is our b value. Perfecto. So then this generic formula here, and you know what, I'm running out of space. So let me just rewrite this over the next slide. So let me y is equal to, rewriting it pretty fast. Okay, so according to our model, since the resting stage is the middle of the graph, there's no vertical translation. And since it already begins at the high point for cosine, there's no phase shift. Therefore, I'm just going to plug in the values here. So first things first, I don't have y as my variable in the problem. I have d. So the displacement is what I have as my variable. Okay, so variable from the problem is d equals, and then we just learned that 5 is the amplitude cosine, and then b value we just learned from the previous slide is 5 pi over 4, 8 pi over 5. And again, the t value right here is what we use in our problem. So we're going to use the t value in terms of seconds. H is 0, k is 0, and then we simplify it all out. And we got ourselves what we need right there. All right, hopefully that was useful. Yeah, there it is, problems in our variable. Okay, hopefully that cleared up what I did wrong on yesterday's class. Thank you so much.